This planet looks almost identical to Earth. Same size, same mass, same distance from the Sun. Smooth, bright, beautiful. But do not be fooled. If you landed here, you would be crushed, melted, and dissolved, all at the same time. The surface temperature is 465 degrees Celsius, hot enough to melt lead, hot enough to glow orange in the dark. How does a planet that looks like Earth become a vision of hell? In 1970, the Soviet Union did something extraordinary. They sent a machine to Venus, the Venera 7, built like a vault, titanium shell, refrigerated core, reinforced pressure seals. The engineers knew Venus was hostile. They had lost probes before, crushed like tin cans before they could even reach the surface. But Venera 7 survived the descent, and for 23 minutes, it transmitted from the surface of another world. The data it sent back was not poetic. It was clinical, cold, horrifying. Surface pressure, 90 times that of Earth, the equivalent of standing beneath nearly a kilometer of ocean water. Your rib cage would not hold. Your lungs would collapse before you could exhale. Then, the signal died. The heat took it. The acid corroded the seals. The pressure finished the work. 23 minutes. That was all Venus allowed. In 1982, Venera 13 lasted 127 minutes. It sent back photographs, an orange, barren landscape under a glowing metal sky. Then, Venus took it back. But in those 127 minutes, we learned something that should have terrified us far more than it did. Venus was not always like this. So what happened to Venus? 4 billion years ago, Venus may have had liquid oceans, or a cooler atmosphere, perhaps even conditions suitable for life. Then, physics turned against it. The mechanism is called a runaway greenhouse effect, and understanding it is not just an academic exercise, it is a warning. Here is how it works. Venus sits slightly closer to the Sun than Earth, just enough that, over time, its oceans began to warm. As water evaporated, it entered the atmosphere as vapor. Water vapor is a powerful greenhouse gas. It traps heat. More heat evaporated, more water. More water trapped more heat. A feedback loop, irreversible. Once it began, nothing could stop it. The oceans boiled away entirely. The hydrogen in the water was stripped off by solar radiation and lost to space. The oxygen combined with surface rock, gone. What remained was a dense atmosphere of carbon dioxide, 96.5% of it, pressing down like a fist, trapping every photon of solar energy that dared enter. Venus became a pressure cooker, a sealed furnace with no off switch. And here is the part that should keep you awake at night. The physics that destroyed Venus is the same physics operating on Earth, right now. But the strangeness goes deeper. On Venus, the atmosphere does not merely exist. It moves. It hunts. At the cloud tops, 70 kilometers above the surface, winds reach 360 kilometers per hour, faster than most Earth hurricanes, and they circle the entire planet in just 4 Earth days. The planet below rotates far more slowly. A single Venusian day lasts 243 Earth days, longer than its own year. Venus spins so slowly and in the wrong direction, retrograde, opposite to almost every other planet, that the sun on Venus rises in the west and sets in the east. This should not be possible. The origin of Venus's bizarre rotation is one of the great unsolved problems in planetary science. No one fully knows why. Some models suggest a collision early in the solar system's history. Others point to gravitational resonance with Earth over billions of years. Others admit, simply, we don't know. What we do know is this. At the surface, the atmosphere is almost calm, but it weighs 92 times as much as Earth's atmosphere. Every square centimetre of Venusian ground bears the weight of a column of air denser than deep ocean water. You would not feel the wind. You would be crushed before you noticed it. And yet, somehow, this is not the most hostile layer of Venus. Between 45 and 60 kilometers above the surface, thick clouds of sulfuric acid encircle the planet. They are what make Venus so bright and beautiful from space, reflective, deceptively pristine. Inside those clouds, droplets of concentrated sulfuric acid fall as rain. They dissolve metal. They would strip organic tissue in seconds. A human being caught in that cloud layer would not die slowly. The acid would not give you time for that. But the rain never reaches the surface. Below about 25 kilometers, the air is so hot that the droplets evaporate. They vaporize before landing. The rain falls and endlessly evaporates. A perpetual nightmare cycle of dissolution and reconstitution. This is the atmosphere of Venus. A system of layered terror, wind above, acid in the middle, crushing pressure and heat below. And at the very bottom, the surface waits. The surface temperature of Venus is 465 degrees Celsius. This number does not fluctuate, not between day and night, not between poles and equator. The atmosphere is so thick, so dense, it acts as a planetary scale heat battery. It stores energy with perfect efficiency. It does not cool, it does not relent. Lead melts at 327 degrees Celsius. On Venus, lead does not exist as a solid. It pools on the surface like water. Zinc, tin, gone. Every probe we have ever sent to Venus has been built from the most resilient metals humans can engineer, and Venus destroys them all. No rover has ever driven on Venus. No probe has survived longer than 2 hours on the surface. The planet does not merely resist exploration, it consumes it. Here is what makes Venus truly frightening. It is not a foreign world. It is not a distant aberration, alien to our own experience. Venus is us, or rather, it is what Earth could become. The same carbon dioxide that drives Venus's greenhouse effect is the gas we pump into our own atmosphere in billions of tons each year. The same runaway feedback mechanism that destroyed Venus's oceans is the theoretical endpoint of unchecked warming on Earth. Scientists are careful to note that Earth is not Venus. We are farther from the Sun. Our feedback loops are different. A true runaway greenhouse here would require catastrophic changes far beyond anything currently projected. But Venus teaches us something fundamental about thermodynamics that no equation in a textbook can fully convey. Energy does not disappear. Heat, once trapped, accumulates. Systems, once destabilized, do not return to equilibrium. They find a new one. And when a planet finds a new equilibrium at 465 degrees, there is no going back. Richard Feynman once said that the first principle of science is that you must not fool yourself, and you are the easiest person to fool. We looked at Venus and saw a twin. For it we saw beauty, we saw proximity, we fooled ourselves. The physics of Venus does not care about our expectations. Heat flows, pressure builds, feedback loops accelerate. These are not opinions. These are not political positions. They are the laws of the universe, written in 465 degrees of molten certainty. Venus did not become a graveyard through chance. It became one through physics, precise, inevitable, indifferent. In the coming decade, we will try again. NASA's DAVINCI mission will drop a probe through the Venusian atmosphere, measuring its chemistry layer by layer, photographing the ancient highland terrain that may hide the last traces of Venus's lost past. NASA's VERITAS mission will map the surface in unprecedented detail, looking for active volcanoes, for geologic change, for any sign that Venus is still alive beneath its hellish exterior. ESA is sending EnVision, a radar mapping orbiter to study the surface, the atmosphere, and the interaction between them. These missions will not land for long. The surface will consume them as it has consumed everything before. But we will learn. We always learn. We just cannot stay. Until then, Venus spins slowly in the dark, glowing, patient, indifferent. It does not know we are watching. It does not know we are afraid. It is simply obeying its physics. The same physics that governs every atom in the universe. The same physics that governs us. Venus is not a warning from another world. It is a mirror.